Hello, hello, welcome back as we're going to continue on in this contest video looking at the 2003 Fryer, question number 3. So how about we take a look at the question right now. Alright, so it's a sort of a graphing question just from the look of the picture we got here, but let's read the question. Always read your questions fully. In the diagram, ABCD is a square, ABCD, and the coordinates of A and D are as shown. So A is at 1, 4. D is at 1, 8. So X coordinate 1, Y coordinate of 8. That's why D is higher than A. Alright, so we're not given a whole lot of information in the preamble. A part. The point P has coordinates 10, 0. Show that the area of triangle PCB is 10. Okay. So, we could figure out the coordinates of C and B, and there might be some way to figure out the area of a triangle using just coordinates. That's certainly something we could try. But because the x-axis and y-axis are perpendicular to each other, I'm thinking we could use CB as a base and figure out whatever the x-coordinate of these two guys is. Figure out the difference between that and 10 and get the height. And use 1/2 base times height for a triangle. So we're trying to figure out the area of a triangle. Immediately we just start brainstorming ways. How do we figure out triangles? How do we figure out the area of triangles when they're on graphs? That sort of stuff. Those are the things that should be running through our head. And then whatever ideas we come up with, I mean, we could probably figure out side lengths maybe. We certainly have a bunch of right angle triangles, and we could use Heron's formula. But the simplest way appears to be sort of a 1/2 base times height scenario. So let's get things going. How about we draw our picture? We'll just draw a copy of our picture on some fresh new paper. So, oops. Let's take a look here. So, try and make our axes as nice and clean as possible. So, not going to exactly be using the grid paper. I know. Why do I even bother having the grid paper if I'm not going to use it properly? D is at 1, 8. A is at 1, 4. We know this is a square, so that'll probably help us figure out the coordinates of C and B. We have a point P down here. P is 10, 0. So if we want to get the area, let's try one-half base times height. So what's our base going to be in this case? It's going to be CB times a height It's going to be the difference in the x-coordinates of P and B. So notice that we can sort of drop this perpendicular down here. So let's say C is going to be at x8, B is going to be at x4. So this distance here will be 10 minus x. Okay, and this will be a height of 4, so we could use that in some way, some other way of doing the question. But I like simplest way is probably the best way. So, length CB times 10 minus x. So we can pretty clearly see that the side length here is 4. We go from 4 up to 8. That's a difference of 4. So what are the coordinates of B? Well, instead of going up by 4, we just go over by 4. So we add 4 to the y coordinates. So it's going to be at 5, 4. The length of CB is 4 because it's the side length of the rectangle. Since x is 5, 10 minus x will be 5. So 1/2 base times height. That'll be 1/2 of 20, which is equal to 10. So PCB has area of 10. I think that's what we were asked to show. Show that the area of triangle PCB is 10. We just did that. Simple calculation. Figured out the side length of the square, and then we were able to, that was the base, and then we were able to figure out the height by comparing x coordinates. Okay. B part, point E, A0, so it's going to lie on the x-axis. So point E is on the x-axis, such that triangle CBE lies entirely outside square ABCD. So it's going to be a point over here, kind of like P. It's not going to be back here, somewhere under AB, because that would cause the triangle to cross over square, the square. So if the area of triangle is equal to the area of the square, so we need to figure out the area of the square, what is the value of A? Okay. So we got some things going on. First, we'll need to calculate the area of the square. That way we know what we're shooting for. But let's take a look at the picture. Alright, just a rough picture of the idea of what's going on. C, D. We know he's 1/8. Extrapolating from last time, we know this guy's going to be 5/8. B is going to be 5/4. A is 1/4. And so E will be all the way out here. So first, let's notice that the square has a side length of 4. We figured that out on the last page. Oops. So area of a square is just, well, 4 times 4. Area of a square is you square the side length. That's where the operation of raising something to the power of 2 gets the name squaring. So 4 squared is 16, so we're shooting for a triangle with an area of 16. So we want an area of 16. Okay. Uh-huh. So first, let's notice that a is going to be greater than 5. So a minus 5 will be positive. All right, we can draw just little sort of pictures like this. Right. So we can pretty clearly see that a minus 5, that's going to be a positive value. We can use the same 1/2 base times height. Same technique. We're still going to have the same base, which is CB, which we know is 4 from the last question. And we know we're looking at a minus 5. Okay. Oops. Started writing the 2 before the fraction line was complete. So 16, that's the area that we want, is 1/2 4 times a minus 5. So that's 2 times a minus 5, 2a minus 10. So if 2a is 26, a is going to have to be 13. Notice that if we were allowed overlap, there'd be 2 possibilities. One where a is greater than 5, and another where a was less than 5. We'd have a less than 5. That would be, a would have to be -3. But we were specifically told that they couldn't overlap, so that forces a to be greater than 5. So a is 13, and that's all we were asked for B part, which is to calculate the value of a. Triangle equal to area square, we did that. All right. C part. Show that there is no point F on the x-axis. Okay, so we're dealing with lots of points on the x-axis. First P, then E, now F. For which the area of triangle ABF, okay, before we've been doing CB stuff, so we had PCB, we had CBE. So there is no point F on the x-axis for which the area of triangle ABF is equal to the area of square ABCD. Okay. So we were able to find a point E that worked just fine. But for some reason, we won't be able to find a point F. Okay? And I'm guessing it has something to do with the height, because it seems like the bases, CB is the same length as AB. That'll be 4, so it seems like the height will cause problems. That's just intuition. We haven't even drawn a picture, but just thinking out loud. So let's take a look at the question. Well, how about we draw a picture? Where might f be? What might it look like if there were an f? So we want to show that there isn't any possible f that works like this. So a good way to do it would be proof by contradiction. That is, we assume that there is an f, and then we show that that leads to an absurd statement. So we'll draw our picture. Try to make this look a little square-like. And we have D up here. C, B, and we have A. And suppose we had F somewhere, I don't know. They seem to have been pretty good with positives. So let's say F is down here. Okay, so I know that this is 4. For example, this guy here is 5, 4. This one's 5, 8. We said this guy's B0. We know he's on the x-axis, so the y-coordinate's got to be 0, but we have no idea what the x-coordinate would be. It's 1, 8. Sorry, that's, yeah, and then this is 1, 4. Okay. So the area of ABF is 1/2 base times height. Okay. Well, AB that gives us a base So notice that AB gives us a base, and from B to the x-axis, or indeed from A to the x-axis, that gives us a height for our triangle ABF. So it really doesn't matter where F is. This triangle is determined. Because F has to be on the x-coordinate, AB is going to give us a base, and the distance from B to the x-axis is going to give us a height. F does not matter. So we can figure out the area of the triangle is going to be 1/2 length of AB times the difference between B and the x-axis. So that's going to be the difference in their y-coordinates. So that's 4 minus 0. The x-axis is always at y equals 0. It's going to be 1/2 4 times 4, which is going to be 8. So regardless of where F is, the area is always 8. We wanted a point F so that the area of triangle ABF was 16, or rather was equal to the area of the square. But we've just shown that no matter where F is, we'll never get an area of 16. We get a constant area of 8. That's because the x-axis lies parallel to AB. There's some deeper math going on there, at least a little bit. So F doesn't matter. Once we said it had to have a base of AB, and F had to be on the x-axis, we were locked into this triangle of area 8, no matter where F is. You can try it at home on a piece of graph paper if you want to set up your diagram a little better. Try F at various points. You will always get an area of 8. And we wanted an area of 16. Well, we're not going to get that. 16 is not equal to 8. And we've explained it. We said, what if we had F? It was some random coordinates. We thought maybe we'd get something like B has to be 1 and B has to be 2, which is a contradiction. But no. We did half base times height formula, the formula that's been working for us the previous 2 questions. And we just noticed that the base and the height were completely independent of F. And that did us in. That fixed the height, the area of the triangle. And I think that's all we were asked. We were just asked to explain or show that there is no point F on the x-axis for which the area of triangle ABF is equal to the area of the square, which we know is 16. So that was a nice little question. I really like C part. It's kind of cool. Got us to think, sort of proof by contradiction-y. At least that was the instinct. But it's a good overall question. I like it. And Friar only has 4 questions, so join me in the next video, if you will, for question number 4. I'll see you then.